So this is a summary for lesson 8. All right, it teaches all about secant, cosecant, and cotangent, and this is the end result. You got to know these things. So I'm going to back out right here, and I'm going to give a summary of what we just learned in this lesson. So first, I need you guys to draw. It's like a unit circle. Let's see here. Okay. Now I'm going to use black, but I'm going to write over the black with different colors to kind of help with the understanding here. Whoa, why is that all squiggly? Okay. So draw a ray, a terminal ray right there, terminal side, and your triangle, and then cap it off. Okay. Then I need you guys to draw me a tangent line that is perpendicular to the x-axis. So it's going to look like this. It's tangent because it's touching the circle at one point. Okay? Just straight up so that it's perpendicular. And then what you can do is you can connect those with a dotted line or a solid line. It doesn't matter to me. Okay? So you should see two triangles that we're working with. Alright, now let's talk about each of these individually. Let's talk about this side right here. I'm going to color it red. Do you guys know which trigonometric function that side represents? Cosine. That is cosine. Oh yeah, I forgot to put in theta right here. Let's put theta right here. That's the angle we're talking about. So this is cosine of theta. And then we have this guy right here. We'll color him green. That side right there. You guys know what that side is. That is sine. That's the height, the vertical leg. And then you also have the hypotenuse. That's just a measure of 1, okay? But the hypotenuse is only the radius. It goes like from here to here. Okay, this is where we started. And then we expanded a little bit. We looked at this line right here and talked about what makes this line so special. Now the distance of this line, the length of this line is tangent. And it's not a big surprise that it's called tangent because it's tangent to the circle right there. And then the last thing that we did was look at this line right here. Alright, let me just darken this up right here. Now what is this line? What is the length of that line? We just learned it yesterday. This is secant. Oh, let's go secant theta. Okay, so we got 4 trigonometric functions represented here. Out of the 6, we have sine, cosine, tangent, secant, all on this little picture that we have. So they all represent those side lengths. Now the most confusing ones I think are cosecant and cotangent. So we're going to bust out another separate circle. So draw me another one. I'll draw a whole new circle right here. So we have some more space. And try to draw the same angle, I guess. It doesn't have to be perfect. So this is theta, and we have a triangle right here. All right, cool. So draw me a line that's perpendicular to the y-axis right there, and go out with it. And then connect this line to it with a dot, so it's connected. All right, now you should see another triangle. Okay, you see this weird big triangle? It's right here. You see that?
Should we color that?
Don't color it yet. That's a weird triangle right there. And I don't like it because I feel like it's not visually appealing. I think it kind of messes with understandings here. So let's talk about them for a little bit. All right, you guys remember? Okay, no. Here, look at this line right here. Now, is there a line over here on this picture that we have that kind of resembles this line?
Tangent.
Tangent.
Just kidding.
Now, I heard some people say cosine, and that's cool. And I'm glad you said that because cosine is horizontal. And you notice that this is a horizontal line, so you were thinking cosine. That's very good. Okay, but tangent, this tangent line has an even closer relationship to it because it is tangent to the circle and perpendicular to the y-axis. So I'm going to use blue to bolden that one. This one right here, folks, is called cotangent of theta. It's weird that they would pull that line out of nowhere. It's like right there. Okay. And then I'm going to show you something really weird here. Okay. I'm going to introduce you guys to a new angle. This angle is called beta. You see beta right here? Beta is the complement angle to theta. Why is beta complement to theta? They are complements of each other because they both add up to 90 degrees. You guys remember your geometry stuff? Well, check this out. Beta actually can give you this side as well, not just theta. We can say that this equals tangent of beta. And beta is a complementary angle to theta. Now, this is all kind of crazy stuff, but we don't really use this triangle to do our trig. We always stick with theta. And so another way to write tangent of beta in this case. Another way to say tangent beta in this case is cotangent of theta. All right, let's draw one more line. Last line is going to be purple again, and this line is similar to a line on our other one. Which line is it similar to? Similar to the secant line. This line is cosecant of theta, which is also the same as secant of beta. Now some of you guys might be thinking, what the heck, that's the same line as this one. Only because this line right here is drawn at what looks like to be a 45-degree angle. In that case, they would be the same. Okay, but over here, if I were to draw a line out to meet that, actually it would be kind of the same. But if you get different thetas in here, besides a 45-degree theta, you would see that cosecant does not equal secant. There'll be different lengths depending on the angle. Alright, now, I just wanted to do this really quick as an overview of all of these trigonometric functions. This is what Lesson 8 teaches you. But the most important thing here is this. You have to know these. You have to know that secant is 1 over cosine. You have to know that cosecant is 1 over sine. And cotangent is cosine over sine, which is the reciprocal of tangent, which is sine over cosine. No more conceptual stuff. Now let's get practical.